Okay, welcome to section 2.4. This is a continuation of what you did in 2.3, and that is establishing truth tables. In the last section in 2.3, we were establishing truth tables using the and the or. And in this section, we're going to be using the if then, the conditional, and the if and only if statements, the biconditional. So what I have is a structure for us as we go through this lesson, and we'll tie it into all the homework questions as well. So the first thing I want you to consider is the following compound statement. And there's a little disclaimer below. I'm using this statement as an example. This is not real. But the statement is, if you pay me $100, then you will get an A in the class. So the important part about starting out with a statement like this is to realize why the truth table is the way it is. So for example, I'm promising you that if you pay me $100, then you will get an A in the class. So all what you expect to happen and what needs to happen is that if you pay $100, you totally expect that you will see an A grade when you look at your e-services transcript, or you get a transcript that's printed. Now, if you pay, the only way you're going to be upset is if we don't meet your expectation. That is, you paid me $100, you're gone, right? Final's been taken, I post grades, and you don't have an A that's posted. Maybe you see a B or a C that's on there. And you're mad, right? Because you paid $100. I promised you something. This is the time that you'll be upset. This is the only time where I failed you in what I promised. Because if you don't pay me $100, that doesn't necessarily mean you won't get an A, right? So think about the situation in the class. Somebody, if I make this offer, is going to be like, no way, Jensen, I'm not paying $100. I got a strong A already, and I think I'll finish out with an A. They don't pay, and they get their A. Another person just says, no, that's not ethical. I'm not paying you. And so they don't pay, and they get their appropriate letter grade, maybe a B or a C. They're not upset because they never took part in the promise. That's exactly the way we establish this truth table. So remember, we have P is what they call the condition, and Q is the outcome. So in this case, P is paying $100, and Q is getting an A grade in the class. And so what we found out is that, well, if we start establishing the truth table, right, and then I'll have it better printed out down here. But if we start establishing the truth table, well, remember our truth tables are always true, true, false, false, true, false, true, false, right? That way we get all possible outcomes. So remember what the first line is. Both of the statements true. Okay, if you pay me $100 and you get an A in the class, then that's what you expected, and that's true. If you pay me $100, right? So if I'm at this level right here, what's happening is we're paying $100, but I'm not delivering on the A. That's the time that you're upset. That's the time where I failed you in my promise. But for these guys down here, if you don't pay $100, then there is no promise. So both of these are true statements. So if you don't pay me $100, you could still end up with an A, right? That's this third line. No $100, still get an A. Totally possible. That's a true outcome that could happen. And then this is no $100 and no A. But you're not upset because you didn't pay the $100, so it's a true statement. So here is the truth table typed out. You can see it's exactly the same as what we have. So as you look at this, it's good to give yourself some language. So language in the books vary. So sometimes P is called the antecedent. What has to happen first. And Q is the consequence. So what you want to say out of this is, oh, if your if statement is false, it's always true. The if then is always true. If the if statement is true, then it's only the conditional is only true if a true goes to a true. You could tell yourself the only time a conditional is false is when you have a true antecedent leading to a false consequence, where you kept your part of the deal, but the consequence didn't happen. So we're going to use this table to answer some homework questions. So this is the first one that you see here is question number 2 in our homework. And so we would just go through, just like in your last homework, you would say, okay, P is true, Q is true. That's given in the problem. And so then we would say, well, not Q. Well, that's false, right? If Q is true, then not Q is false. So P implies not Q. P implies not Q. A true implies a false. Well, a true implies a false is the only time it's false. And so we'd have a false there. So I'm not sure if I can highlight in here. Oh, it looks like I can. But we're in this row right here. True, right? P is true. Not Q is false. P implies not Q is false. Using that guy right there. All right. So with that problem done, I'm going to back over this one if I can. Let me just get down to here. It's not letting me do that. So we'll just keep rolling up and down to those. Let's look at this number 6. So we have P is false, so not P is true. R is false, so not R is true. And then they want us to and together not P and Q. So they're going to rely upon your old skills. So not P is true, Q is false. And if you remember and's almost always false. The only time an and statement is true is if they're both true. But here I have not P, which is true, right? I have not and Q, which is false. So because that Q is false, this guy right here is false. And if I scroll down a little bit more, they have the not P implies Q. I'm sorry, not P and Q implies not R. So that's these last two columns here. Right? I don't know if it will let me highlight them, but it's these last two columns right here. And the direction makes a big difference. So remember, we're going from the not P and Q column to the not R column. So that's a false going to true. If I come back up here to my truth table, whenever you have, oops, it will let me write on that. But whenever you have a false implies anything, the whole thing is false. I'm sorry, it's true. Okay, sorry, I get a little bit trying to fix what I did here. But we have a false implies true, right? We have a false implies true, and so we know that that is true. And so that's what we have for that one, and that completes those. So you'll do these ones. We'll also do a biconditional. Biconditional is the if and only if, and I used this example already in class, so I thought I would bring it back up again. And this is still related to the grades. You will get an A in the class if and only if your overall percentage in the course is 90% or better. That's the promise I made you from the beginning of class. And so it goes both ways. If you get 90%, then you absolutely have an A. If you get an A, then you must have had over 90%. And so as we look at establishing this truth table, let's let P, if we go look at this, let's let P be getting an A in class. And we'll let Q be overall percentage 90% or better. Okay, so if we think about the biconditional, we want to view it through the lens of the conditional. Okay, so this is P, and then both ways, arrow going both ways implies Q. Well, you know how to establish truth tables, right? You'll do that even at the end of our section. True, true, false, false, true, false, true, false. So if we go to the first one, the arrow's got to go both ways. So true implies true is true. And if I go backwards, so if I go this way, true implies true, true. True implies true, also true. True implies false, false. If any one of them is false, the whole thing's false. False implies true. Oh, that's true. But true implies false is false. And false implies false is true. False implies false is true, so this is true. So with the biconditional, they would only hold if both statements have the exact same truth value. So essentially what I'm using is the information up here. Not sure if it will allow me to copy this in a good way. Nope, not that. Okay, but I'm using this chart right here to talk about it. So from that table, we know true implies true is true, true implies true is true, so the whole thing's true. We know from that upper table, true implies false is false. And so that makes the whole thing false as long as one of them's false. False implies true is true, but true implies false is false. And then false implies false is true, and false implies false is true. So whether you feel like you understand that or not, I do want you to spend the time trying to understand that, and we can talk more about it when we are in class together. But here is that truth table that you're going to rely on. So let's look at problem number 4 from the homework. As we go to do problem number 4 from the homework, we have P given to us as false, Q given to us as true. They were asking us to find not Q. Well, not Q is easy. That's false. And now we need P if and only if not Q. So let's see if it lets me write here. Don't know if it will. We are going from this box to this box. Okay, kind of let me show you. So that's false implies false, and we are also going back, and false implies false. Well, it's biconditional, so we got two false statements equated to one another. So according to our table up there, it is true because no promise has been made for what happened there. All right, so as we go to something like number 8 and see what's happening there. See if I can bring this up higher. That way we have that table right above us. Okay, this is a longer one. They're giving us P is true, Q is false, and R is false. So not P is false, not R is true. And now we got not P and Q. So remember what's happening there. Not P, see if it will let me draw again. Not P and Q, right? So we're putting these guys together. So not P and Q, well, you got a false involved in both cases, but that doesn't need to happen. As long as one of them is false, the whole thing's false. So this is a false statement. So if I move down here, now we have not P and Q, if and only if not R. So because they don't have the same truth value, not P and Q is false, but the negation of R is true. Anytime they have different truth values, the biconditional is false, right? That would be these two columns right here. It's going on there. And so this is going to be false. And we're finished with that problem. Okay. So just relying upon that table, but hopefully understanding. So I'm looking at this biconditional, and the biconditional is true only when both truth values are the same. So here I'm given that P is true, Q is true, R is true. Now I'm going to look for the negation of P, which is false, the negation of R, which is false, the negation of P and Q. They like that today. The negation of P is false, Q is true, false and true from your last section is false. Now they got P implies R. So, sorry, the negation of R. So let's see what P is. P is true. The negation of R is false. So and that's the applies one. So that's not the one we have there. So let's go back up here. P is true. The negation of R is false. So we're in this second row. We're getting our answers from this second row right here. And so the outcome is false. So we'll come back down here and say, hey, this is false. We're not done. Now they need us to do the biconditional with these two statements, the negation of P and Q. If and only if P implies the negation of R. Well, since they're both false, I'm in that last row in the one right above, right, in this table, in the biconditional table. Since they have the same truth value, the answer is true in the end. Awesome. So we're going to construct, the homework's going to finish out, by constructing full truth tables. So let's see how that's going to be done. So let me get rid of this. And what I want to have is quick access to these tables as we need them. And it looks like I'm only going to need, for the examples that they had, the conditional statement. So let me back some stuff up here and see if we can get that truth table closer. So again, what we're finishing off with is a full truth table, and they're going to have the conditional and biconditional in there. The two even ones that I chose just relied upon the conditional. Okay, and so we're going to back up over here and get that table where we can see it more readily. And that's the truth table that we are going to be using, it looks like, for this problem. Okay. I don't want to get rid of that one, but I think I can get rid of this one. Okay. So let's look at number 22 here. And these are the directions for 22 and the ones in that block. All the other ones are just single lines of truth tables. This one's going to ask us to do a full truth table. So looking at this, we have the negation of Q implies P and not Q. So what we have to remind ourselves of as we go to do this is, well, who comes first? Let's do as much as we can before we answer that question. So remember, we're being asked to construct a truth table. So hopefully that automatically puts something in your mind. And that is that you have to create a big table. So we're going to have, get the right pen here. We're going to have the things that are set in place. We're going to have P and Q. P, we know, starts out as true, true, false, false. And Q alternates true, false, true, false. So that we get all possible combinations of when P and Q are true and false. That's what a truth table does. It gets all the elements out there. We know that we're going to need the negation of Q, but let me do something really quick. Let me highlight that. From the problem, we're going to need to know the negation of Q. That's something we're adding based upon what we're seeing. Now what I don't know is, what should I do next? Is this the negation of Q implies P? And let me write that out. Is this being viewed as the negation of Q implies P? Do that first and then the negation of Q. Or is it the negation of Q implying P and negation of Q? This way. I mean, those are two big, majorly different things. And it all depends on how you view it. Well, you can remember your first homework. No, actually it would be your second homework assignment, the 2.2 section. You had to put parentheses in based upon order of operations. So let's remember that. Let's see. Remember, we had two things involved, an and a conditional. And it looks like, according to this table, the first thing that we would do is the and, or the or. And then we would do the conditional. So it's in order from top to bottom, what you do first and what you do last. So based on this, we would be doing not the top one. Let me come in here and get an eraser. we would not be doing this one because that has us doing the implies first. This is what we would have. So we would want to then say, okay, let's keep going. We need to establish the P and not Q row, and then, or column, and then we need to establish the not Q going to P and not Q. So that exercise that you did back in 2.2 is really important. They're going to continue to test you on your ability to know the order of operations. So it sounds like a good thing to include in our notes. So let's go through this column by column. Not Q, that's easy. That's just the opposite of what Q is. So that's false, true, false, true. P and not Q. So what do we remember about and? They've used that a lot in our examples. We remember and needs them both to be true in order to be true. So looking at the very first one, we have, let me try to use a highlighter. Maybe that would help. We have P and not Q. P and not Q. P and not Q. P and not Q. Those are the columns that we're looking at. And as we look at those, we can see that we need them both to be true in order to be true. The only time it's true is right here. All the rest of them are false because somebody in that mix is false. So we only get one true statement out of there. I'm going to go through and erase my highlights. Okay, those were the columns that we were looking at. And now let's do the not Q implies P. So let me come in here with the red pen. Remember, what we're doing is not Q implies P and not Q. So we're looking like that. So as I look at this, go back to my blue pen, false implies false is true, right? So I'm go back to my red, false implies false, true implies true, false implies false, true implies false, right? And then I'm remembering this table up here. So false implies false. That's right here, right? And so that's true. That's why I have a true there. True implies true. That's the top one. That's true. Okay, and I'll go back and put that in the same red color if it lets me. Or sorry, same blue color. True. False implies anything is true. True implies false is the only time it's false. And that's what our truth table looks like. A true, 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 false outcome. Right? But it was important to know what my order of operations were. Let's see. So now we have this 26 problem. And as we go look at 26, you can see that they have some parentheses around, but I got to still pay attention. So to what the order of operations is. So again, we start out, and I'll highlight that in black. What's in black is the main structure of a truth table that never changes. True, true, false, false. True, false, true, false. And then we have things that are unique to our question, right? That's where I start out with every truth table. What makes it look different is what's in the question. So looking at what's in the question, we need a P implies Q. Remember that and comes before implies, but I do parentheses first. That's why I'm doing that guy, the P implies Q. So the next thing to do, because and takes precedent, is P implies Q and P. And then the last thing to do is everything you see there. P implies Q and P, implying, and I'll use brackets here just to highlight, implying Q. Extend some of these lines out here. Okay. We need to get the truth values in that last area, and we're done. So I'll put our answers in red. P implies Q. That's just the truth table rewritten. So true implies true is a time where it's true. True implies false is the only time it's false. All of these rest are true. Why? Because if you have not fulfilled the condition, the antecedent, there's no way you're expected to meet the conditional. So the only time a conditional is false is if a true implies a false. Now we're going to use those with the and. So now remember what I'm looking at. I am looking at this anded with the P. So I'm looking at all these guys anded together. Remember, and needs both of them to be true in order for the whole thing to be true. So they're both true up at the first one, but there's a false one next, there's a false one next, and there's a false one next, right? So that last one's false because P's false. The second to the last is false because P's false. The second one down is a true P and a P implies Q being false. That's false. I need them both to be true and an and. Awesome. So now we get rid of these highlights because I'm not looking there anymore. Now I'm looking at, and I'll use my red pen here. I'm looking at this guy implying this guy. And the arrow direction makes a big difference. So I have a false implying a false. Well, that's true. I have a false implying anything. That's true. I have a false implying anything. That's true. Okay. And I have a true implying true. That's true. So they may not mentioned it yet, but when this happens, they call this a tautology. Because it means it's always true. So this is a nice, valid statement. No matter what's said, it will always be true. Okay, so that is kind of a foreshadowing of evaluation of arguments. If you look at what's being said, it's saying, hey, we're promising you P implies Q. And you know what? P happened. So therefore, Q has to happen. It makes complete logical sense. Hey, so if I phrase it in the way that my original one was, pay $100. If you pay $100, then you get an A. That right there is the P implies Q part of it. Then what this part is right here is, oh, you paid the $100, right? Because that's what P is. So therefore, what should happen? So you should get an A. So you just found out that, okay, it's maybe something you already know. Hey, I promise you, if you pay $100, you'll get an A. You paid $100, therefore you're gonna get an A. A nice, valid argument. The fact that it all came out to be true shows us that, and they called that a tautology. So maybe a little bit of foreshadowing from the section that are to come, but our job is to get familiar with the conditional and the biconditional, and play around with it, have fun with it, and then we will talk when we're back in class.